Situation that comes up pretty often in mathematics, especially in algebra classes, is one where you've done some kind of calculations, and your final result, rather than being a single number, maybe two or three numbers, is a range of numbers. For example, all the numbers between 1 and 4 inclusive, all the numbers strictly greater than -1, all numbers between 4 and 7 including 7 but not 4, this kind of thing. Right? It'll usually be expressed with some kind of inequality at the end of your calculations. So what we need is a more concise way than this to describe these kinds of things. And we already have one method that you've probably seen. It's called the set builder notation. And the set builder notation is great. It's definitely more concise, and there are situations where it's definitely the way to go. But when we have a situation where we're talking about an interval of real numbers, which comes up a lot in algebra, pre-calculus, calculus, even trigonometry classes, there's another notation we can use called the interval notation that is even more concise than this one is. Right? And that's what we're going to talk about here. So how do we actually do this? Well, when we're writing a range of numbers using the interval notation, there are two things that we really need to focus on. The first thing is, what are the endpoints of the interval? And the second thing is, do we want to include those endpoints or do we not want to include them? The interval notation gives us a way to express both of those key points. So let's take a look at the first one here. All numbers between 1 and 4 inclusive. Right? So that the inclusive, that means we want to include 1 and 4 in our final result. So the way I'm going to do this is I'm going to start by looking at the endpoints. Right? The endpoints of my interval are 1 and 4. So I'm going to put them down first, and I'm going to separate them with a comma. That takes care of the first part. Right? We've got the endpoints here. Now I need a way to say specifically that I want to include 1 and include 4. And the way I'm going to do that is I'm going to put square brackets here on either side. And that's it. That is the interval notation for all numbers between 1 and 4 inclusive. All right, so let's take a look at the second one here, because this one is a little different. This one is the opposite of inclusive. Now I want all numbers strictly greater than -1. So I'm not going to want to include -1 in my final result. And what makes this one a little different is that there's no explicit mention of one of the endpoints. There's only one number here. It's -1. Okay, so how do we handle this? Well, I think it helps here if we take a look at this visually. So I've got a number line here, and I've got -1 on it. Right? And I'm going to start at -1, and I'm going to put an open circle. You remember, if you've seen this before, we use an open circle to mean not include that point. And then what I want are all the numbers greater than -1, to the right of -1. Okay, so you can see, if you look at the visual representation here, that there is no right-hand endpoint. Right? It keeps on going forever. And that's okay, because the interval notation has a way to handle this. I'm going to start by putting my left-hand endpoint, that's -1. And for my right-hand endpoint, I'm going to put plus infinity. Now, I always put the plus sign, but it's just a habit of mine. If you just leave the plus off and put infinity by itself, that will be fine as well. All right, so now what am I going to put in the ends? Well, the strictly greater than -1, remember, that means that I do not want to include -1. The way I'm going to indicate that is with parentheses. Right, so I'll put parentheses there. And what am I going to put on the infinity side? Well, this is an easy one. Infinity plus infinity on the right, and if there'd be a negative infinity if we needed to do that on the left, those always get parentheses. Right? To kind of see why, it helps to remember this interval notation. It only applies to sets of real numbers. And plus or minus infinity are not real numbers. They're just a kind of a notation that we use to say it never ends. Right? But because they're not actually real numbers, we're never going to want to include them, so we're always going to put parentheses. Okay, so how about 4 and 7, including 7 but not 4? All right, well, I'm going to start the same way. 4 and 7 are my endpoints. I want to include 7. To include, we use a square bracket, but I don't want to include 4. Okay, well, if we don't want to include, we use parentheses. So you can mix and match, or you can mix and match the parentheses and the square brackets as necessary, depending on what you're doing at each of the individual endpoints. So to just kind of summarize what we talked about there, and how you do this notation, we start off with the left endpoint. Could be a number, could be negative infinity. Then we do the right endpoint. Again, could be a number, could be plus infinity. And then we think about what we put at the end. We put square brackets if we want to include the number. If you're looking at this, if you've got something in the step builder notation, for example, you're trying to rewrite it in the interval notation, less than or greater than would indicate that you're going to use square brackets. And you're going to use parentheses for doesn't include. Again, if you're thinking back to the interval notation, that would be a situation where you have strictly less than or strictly greater than. All right, so in the next lecture, we're going to take a look at another situation that kind of comes up in algebra classes sometimes, where you have multiple intervals, and your answer is either the intersection of those intervals or the union of those intervals. And we want to take those intersections and unions and condense them down to hopefully just a single interval. A lot of times we'll be able to do that, sometimes we won't, but we'll see the specifics in the next lecture. So if you like this presentation, please don't forget to click on the like button down below. There are some additional links here that you can use to get to that next lecture.